All right, we are in. Over to Siva. Siva.
Yeah, hi everyone. Good evening. How many of you attending first time? Okay, so mostly. Okay, thanks for joining us today. Okay, so we are K8SUG group. Yeah, we are the most active Kubernetes and AI meetup community, and we have 14,000 plus followers in Meetup. Yeah, members in Meetup group, and then 9,000 plus followers in LinkedIn. Okay, so yeah, our mission, we are very passionate about Kubernetes technologies. Our mission is to accelerate Kubernetes adoption. We're learning from each other. Yeah, if anybody interested to speak regarding to the Kubernetes technologies, we are welcome. Okay. And we have a global footprint in Australia, Melbourne, Sydney. Yeah, within Australia, Melbourne, Sydney, and Canada, and UK, and then yeah, again in Singapore. Okay, so we do have new in Philippines as well. So today we have a topic about a scaling with Karpenter on EKS, which is on AWS cloud. So yeah, Gladwin you will take care of session. Sorry, Gladwin you, right?
It's Gladwin.
Gladwin, yeah, some typo. Sorry about it. Okay.
Gladwin Neo is the solution architect for AWS. Container specialized.
So our main sponsors are Code Cloud, and our main sponsors for the today event, Code Cloud and AWS. Thanks for AWS for providing space and then arranging snacks. So here is our main team for Singapore, Kangkang and Fazir, Ritesh, and myself, Siva, Ram, Fatima, and Jignesh. Okay, so here are some of the upcoming events. 15th August in Australia, and 29th August in UK, and then 4th of September in again Australia, Melbourne. Yeah, for those who haven't joined, yeah, if anybody willing to join as volunteers or take a sessions as a speakers, please do register. And if any sponsors, yeah, we are all welcome. And yeah, please follow us on LinkedIn, Twitter, and Telegram. If you are not at member of these groups, we do have LinkedIn, Twitter, and Telegram. Okay, moving to next. Yeah, here is another program, Kubestronaut program, where it is all about completing all these 5 certifications with the Linux Foundation, CKA, CKAD, CKS, and KCNA, KCSA. So we do have exclusive coupons for 5 certifications. Currently, there is a promo code is running. If in case anybody interested to enroll, yeah, we do have a promo code for all 5 together, a bundle, or yeah, 25% for some of these. If in case each one, I think 38+% if in case you would like to go with a single certification as well. Okay, so we have 8 Cubastronauts in Singapore. In Singapore, okay, yeah. So they're all donating. Yeah, they are all donating 50% of vouchers. When they certified, they will get all these vouchers. So they are donating for the community as well. Thank you all for those who are donating. And yeah, here are some of the promo codes which I was referring. If in case you are interested to go with the certifications, please use these promo codes. Yeah, this was the I was referring 48.5% for Cubastronaut, which comes with the a bundle of all certifications. And I think there may be other one 47%. There is another one for code cloud promotion. If in case anybody looking for a learning platform access, which is a code cloud where they provide all these Kubernetes and DevOps learning tools. Yeah. And there is another one recently introducing AWS Astronauts program, which is again all these combination of available certifications within AWS. Okay, so yeah, for those who wants to, please follow the LinkedIn and for more updates. So here is our AWS astronaut who is our founder. He's already completed. And yeah, there are landing page. There is a new landing page introduced by K8SUG. Okay, so yeah, maybe you can follow https://k8sug.com. Yeah, you can please scan and then feedback. Okay, so I will now invite Mr. Gladwin Neo to take over the session. Thank you.
I'm not going to use the mic, but can everyone hear me? Okay. So I'm going to ask a different question. Previously, I think someone asked if it's your first time attending. So I want to ask if anyone is like the second or third time attending. So the first time it was held here was, I think, 2 months back when we celebrated the 10th anniversary of Kubernetes, where there's like a huge cake. So who attended the event? Okay, maybe half. Okay, so who knows about what Karpenter is? Okay, less than half. So that's actually a trick question, because if you don't know what Karpenter is, my colleague during the event, he actually briefly talked about Karpenter. So if any one of you still don't know what Karpenter is, you're probably not listening to the presentation. But it's okay. It was only briefly mentioned, so I'm going to go slightly deeper today. So today you can see the room is not fully filled. So if there's anything you want to ask, you want to stop me or anytime, like just feel free to stop me. I mean, there's only so many of you here, and I can just take any questions. I mean, since we have quite a lot of time as well. So today we are going to talk about scaling with Karpenter on Amazon EKS. So what exactly is Karpenter? Karpenter basically in a phrase is just cluster autoscaler with steroids. So how many of you know what cluster autoscaler is? Okay, not a lot, which is a bit surprising and a bit concerning. It means that you are not scaling your applications at scale. Maybe you are developing a demo environment, testing environment, but it's okay. Everyone is here to learn. So if you don't know what cluster autoscaler is, it's basically an open source tool that, together with Kubernetes, when Google developed it, you have to scale your worker nodes. So cluster autoscaler is essentially your worker node scaler. So only 4 basic things I'm going to talk about today. First one, what is Karpenter? Second, how Karpenter works exactly, how it slightly differs from cluster autoscaler. some of the synergy that Karpenter brings with you with regards to flex compute and allowing you to mix and match all the different CPU architecture type. And lastly, what are some of the best practices you can achieve with Amazon EKS together with Karpenter? Right, so in terms of scaling your application, typically what happens is your HPA or your horizontal pod autoscaler will start scaling first. So this can be done typically through CPU utilization, memory, just very basic. So what happens if you set it at a specific threshold such that at 70 or 80%, your pods can't handle any more requests. So you look at the extreme right, you see that there's a threshold. The moment it passes that threshold, then you will start scaling up. So these are not scaling your actual nodes. These are just scaling your pods, which are your container applications. So typically, the first step would be to scale your pods first before you scale your nodes. And in the event that your nodes cannot hold any more pods, because based on your, let's say for a very basic requirement, a node can only hold 10 pods because these 10 pods are requesting a certain number of CPU as well as memory. But at the 11th pod, if you can't scale up anymore, it will become unschedulable because it's really maxed out. It's just like when you're trying to fit something into a car. If it's maxed out, you cannot fit anyone. You have to have another car so that the additional person can get into the car. So same concept. So in this case, Cluster Autoscaler will then scale up your additional nodes to house these pods so that the Cube scheduler can schedule these pods into the worker nodes. So let's say in this example, you look at the top. So just take it that 1 square corresponds to 1 CPU. So in total, you're requesting 7 vCPU. But look at your nodes right here, running 4 vCPU and 16 gig of RAM. There is no way it can house a total of 7 vCPUs because there's no more nodes. So what Cluster Autoscaler do, it will spin up 2 additional new nodes. So these 2 new nodes will total equate to 8 vCPU. So the moment it has scaled up the new nodes, the Cube scheduler will then schedule these two application or workloads into the new nodes. So that's typically how your Cluster Autoscaler works in general. So why are we here? Like, why can't we just continue using Cluster Autoscaler? Why do we even need Karpenter? I mean, what are we trying to do here? So if you notice, right, when you're using Cluster Autoscaler, you can only scale as much as how many node groups you have. So let's say you have diverse workloads that requires different instance family, different vCPU, different gigs of memory. How many node groups are you going to create? I mean, managing Kubernetes is really difficult, but if you want to manage the number of node groups that you have, it's going to be complex as well. So the whole idea of why Amazon came out with Karpenter is because we want to remove the concept of node groups. We call it groupless node groups. So essentially node groups that you know when you go into the console, right at the bottom, you can see create a node group. So essentially, when you're using Karpenter, you don't have to create multiple node groups because all you need is just the base layer of the node group to house your Karpenter pods. And then subsequently, when Karpenter scales, you won't be creating any node groups. So essentially, it doesn't go through auto scaling group in AWS. It really hits the EC2 Fleet API to provision new nodes. And this really makes it more flexible because let's say you have like tens or hundreds of workloads that you have to scale based on your specific CPU, memory, instance family. You want M, you want C, you want G, you want to have a x86 CPU architecture, you want to have ARM64, you want to have on-demand, you want to have spot instances. If you're using Cluster Autoscaler, all of these has to be created using the node groups. But if you're using Karpenter, everything is done through the custom resource definition file or the YAML file that I'll show you later. So essentially, it provides a lot of flexibility and control over what you can do. You can mix all the instance type that you have, or the different vCPU, or the memory requirement, CPU architecture. You want to have a spot or on-demand, everything can be just done in one single YAML file. So essentially, removing the node groups provide a lot more flexibility than what you can do with Cluster Autoscaler, which still uses managed node groups. And Karpenter also has a very interesting feature that we have, which is consolidation. So what if maybe when you're scaling up and down, the new nodes are spun up? What if there's a chance that you can reduce the overall cost of your cluster if you manage to scale it down or to bin pack everything into a new node? So assuming that your workloads can move nodes. So okay, some of the customer workloads that we work with slightly more strict. They like the workload to stay in the pod. They don't like stay in the node. They don't like it to jump around. But assuming that you are okay with your pods jumping around the nodes, we have a consolidation feature which essentially moves all of your pod into one new EC2 instance, which is a lot more optimized. And it will also bring down the cost of the cluster because instead of running maybe, I don't know, two large machines, you might be able to bring down the cost of a cluster by running maybe 3 small or maybe 2 medium machines or maybe 1 medium machine. So that's how the consolidation feature works. And all this is done automatically. You don't have to predefine it. It's done intelligently. Of course, if you have strict requirements, you can also just disable the consolidation feature. So likewise, going back to the example, you see that previously in the example that we have, let's look at top and bottom. At the top, previously we mentioned we need to have like instance type of 4 vCPU, 16 gig of memory. By using Karpenter, right, if you don't have any strict requirements, you can just leave it open, leave it as default, and every instance, every CPU architecture will be considered by default. So by default, if you don't specify anything, Karpenter will automatically pick the cheapest version or cheapest instance family for you. So that means to say that, let's say, if all of us are operating at a, I don't know, M5.large instance, you would pick M5.large as well as spot instance because that spot costs cheaper than on demand. So by default, Karpenter already have you in mind how to cost optimize every of your cluster that you have and just pick the cheapest one for you. So in this example, coming back to what we've discussed previously, you are requesting 7 vCPU, but there's no new nodes. So Karpenter spins up one new node, one instead of 2, just one new node that has 8 vCPU. So how it does is, why is it acting differently from Cluster Autoscaler? Because Karpenter has this very interesting feature where it batches of or aggregates all the resources and spin up one new EC2 instance that can house the workloads together. So essentially, right, I think I'm able to show a demo later and you can see how it works. Instead of having 2 M5.large to house 2 workloads, Karpenter spins up one C6, I don't know, X.X large and house all the workloads inside. And it brings down the overall cost of your cluster because it actively selects the cheapest one for you and bin packs everything into one big EC2 instance for you. So essentially, once the new node has been spun up, Kube Scheduler schedule all of these pods into this new node and your container applications are up and running. So this is just a pictorial form of how Karpenter works. Likewise, it works the same as Cluster Autoscaler. The only difference is that it batches everything together. So instead of creating 2 new nodes, it creates 1 new node because it looks at these 2 container workloads. They are requesting 7 vCPUs in total. So when you're using Cluster Autoscaler tend to view them as different. While using Karpenter, it batches everything together and provision one new EC2 worker node or your EC2 instance, and then your Kube scheduler will schedule all of them into this new node. So this is not much different fundamentally as to how you're scaling your nodes. The only thing different is that Karpenter batches everything together. And the next reason why Karpenter is better, because Karpenter in simplicity works a lot faster. Okay, I wouldn't say a lot. It actually depends on your workload. But essentially, Karpenter works faster than Cluster Autoscaler. So why? Okay, so let's look at the traditional way of scaling your worker nodes. So Cluster Autoscaler. When your pods go above the threshold, you have to scale it. HPA kicks in. You have pending pods. Kube scheduler has nowhere to put all these pods. ClusterSugar looks at the pending pods and then sends a request to ASG. So ASG in this case means Amazon Auto Scaling Group. So AWS Auto Scaling Group, the one when you're hosting your EC2 instances, your Auto Scaling Group. So CA tells ASG, I have not enough nodes to house all of my pods. Please create new nodes. And then an ASG will then hit the EC2 API, update ASG from, let's say, 2 to 3, because I need to have new nodes to house these pending pods. And then when this node is successfully being spun up, Kube scheduler will then schedule the pods into these nodes. So how does Karpenter work? So again, we go back to auto scaling. If it goes past a certain threshold, you spin up new pods, and if there's pending pods, Kube scheduler has nowhere to put it. Karpenter then comes in, looks at the pending pods, and should we hit the fleet EC2 fleet API. So you can see essentially we are bypassing ASG. So when you are using Karpenter, right, you don't have to. If there's something that goes wrong, if it's not scaling as expected, there's no point in going to EC2 ASG to see what's going on. You won't see any ASG there because it doesn't work with ASG. So this is why it's called groupless. We don't work with ASG. We straight away hit the fleet EC2 fleet API directly. So if you're trying to debug, there's no point in going to ASG to see how come it's not scaling. I'm supposed to have 4 nodes. Why aren't my nodes scaling? You won't see anything there because we are removing that concept, which is why essentially we are skipping step and why Karpenter will work faster than CA. So also Karpenter provides bin packing. So if everything can be squeezed into one EC2 node, you can. But that's assuming that you don't have any strict requirements. Let's say for example, for some reason or another, you don't want to achieve HA. So everything can be packed into one EC2 node into one availability zone. Karpenter does it for you by default. But if you want to customize it, you can use a combination of node affinity, taints, and toleration to make sure that everything won't exist in one single node. So let's say if one single node fail, at least the other node with your container workloads can still work as expected. So what about scaling in? Again, it works faster because we are bypassing ASG. We won't tell ASG, hey, my workloads are underutilized. Change my desired size from 3 to 2 because I don't need 3 worker nodes. I only need 2. Scale down, move the pods over, and then queue off one node. So essentially, Karpenter works a lot faster because we don't talk to ASG. If we see that there's underutilized nodes, we shift it to a existing node if we can, or if we see that there's a chance for you to bring down the overall cost of a cluster, spin up one smaller or medium-sized EC2 instance, shift everything over, and then queue off the other nodes. So with Karpenter, everything is done through the Karpenter CRD. Everything will be done through a YAML file. You want to have on demand, you want to have Spot, x86, ARM64, everything can be done. Even the different instance type that you want to have, M5, C5, G. The only thing that you can't put in is bare metal. I don't think it works for now. But again, it's a rather niche use case that you want to use bare metal. But essentially, every of the instances which are more commonly used amongst customers, all of it can be included. So this is how the custom resource definition file will look like. We call it node pool. It has gone through certain changes. So now, previously it was called provisioner. Now it's called node pool. So you can have one single node pool, or what we call one single provisioner to rule them all. So every of your container workloads can run on one single node pool. So every of the container workload will have these characteristics. You can choose either M5, C5, R4. It can be either availability zone 2A, 2B. You can either have Spot, you can either have on-demand, or you can have different CPU architecture. So every workload, regardless, I don't know, if you're running distributed system, microservices, your login, authentication, card, checkout, everything will be based on this single node pool CRD. Of course, there is also there's also flexibility to mix and match different provisional or node pools to fit your different workloads. Let's say, for example, the checkout microservice is handling more requests than authentication, for example. I'm just giving a very generic example. You will want probably a bigger instance size, or you probably want on demand because it needs to be up and running all the time, while your authentication or sign up service can run on spot because there's no requirement for it to be up and running all the time, for example. So you can mix and match. So it's not uncommon to see that in one single cluster, you have multiple node pool. Of course, if it gets too complicated, you can always default it to just use one single node pool. It will work. But if you want to have more flexibility, you want to have more control over what your apps can do, cannot do, or what your apps require, then by all means spin up multiple node pools or provisioner to suit your workload. So you can see we have flexibility over instance type. If you don't put anything here, all of the instance from M, T to G, everything will be considered. So Karpenter looks at what your pods or your container workloads are requesting, and then spins up a more cost-optimized EC2 instance for you. You can dictate which availability zones these new worker nodes will be housed in. If you want to save costs, you want to have spot or on demand. If you don't mind your workloads running on spot, then by all means put spot and on demand. But by default, since it chooses the cheapest EC2 instance for you, everything will be spot. So the only time where if you put spot and on demand and spot isn't successfully being spun up is because there are no spot instances. So let's say, for example, M5.large running on spot instances is like the most popular out in the market. If Karpenter cannot find your M5.large running on spot, then it will just fall back to on demand, assuming that that's already the cheapest alternative. Let's say, for example, if C5 large running on spot costs the next cheapest, then of course the spot instances will be spun up. But if you don't see the spot instances being spun up successfully, it will probably mean that there's no more spot. You only can fall back on demand, which is why it's also a strategy to include as many instance type as you can, because you don't want a situation where you're trying to save costs, but Karpenter keeps spinning up on demand, and you come back to us saying like, how come you promised me that you will bring down the overall cost of a cluster, but every time instead of spot, it spins up on demand, because the instance type that you selected only can run on demand because there's no more supply of EC2 instance or for your spot to run on. So as you can see, in terms of CPU architecture, ARM64 and x86. So again, by default, ARM64 will be spun up because it's not typically cheaper, or in most cases, if not all, cheaper than x86 instances. So the second type of CRD or custom resource definition that you probably have to take note of is something called node class. So essentially, you just specify your security group, where your subnet is, and if you're running stateful workloads, what kind of like blob device mappings that you have. So EBS, EFS, all can be configured. So like cluster autoscaler, when you scale up, you want to have certain requirements. Both pods can't be in the same node. One must be in here, one must be the other in another node. All of these can be configured. Hints and tolerations, node affinity, node selectors, everything can be configured. So it's safe to say that whatever cluster autoscaler can do, Karpenter can definitely do. So there is practically no reason why you shouldn't be using Karpenter. Unless, so Karpenter can't do one thing, which is GPU slicing for now. It has really been brought up in GitHub issues. I think the service team is currently working on that. But if you're running ML workloads, you want to be a little bit more cost optimized. You don't want to use the full GPU. You want to use like a quarter or half of it. Karpenter is not smart enough yet to do that. So keep in mind. So coming to Spot, if you're running Spot with Karpenter or running Spot instances with Karpenter try to provision Spot instances, whatever that we recommend for your EC2 instance, for example, everything stays the same. You want to select a price capacity optimized Spot. So it balances between price as well as capacity. If you go full on price, you might not get capacity. If you go on capacity, you might not get the cost savings that you really want. And also, diversify and don't constrain refers to the fact that it's generally advisable to provision or to state more than one EC2 instance that you have. So in the previous example, I think we had quite a lot. But in the case where you only put M5.large, C5.large Spot on demand, if you're unlucky, both M5, C5 not available for Spot, it will definitely fall back on demand because that's the next best alternative. Then of course, your entire cluster won't be as cost optimized as you hope because you only specify 2 EC2 instances to use. But if you have like 10 EC2 instance and you specify both Spot and on demand, then there might be a chance where 2 of them don't provide Spot instances, but the rest of the 8 can provide, and it will also ultimately bring the cost of your entire cluster down. So likewise, in terms of interruption, pretty standard. If you're not already running it in EC2, in the EC2 setting, when there's interruption, you get like 2 minutes, yada, yada, yada. So everything stays the same. There's nothing different. So in terms of best practices, these are some of the best practices we have. So with regards to Karpenter, we generally do not run the Karpenter pod. So when you're using Karpenter, Karpenter is typically deployed as a pod. So if you have 2 instances and you specify 2 Karpenter pods, both pods, in order to maintain HA, will be residing in different nodes. So typically, we don't recommend that you run the Karpenter pods onto a node that is managed by Karpenter. So what does that mean? So let's say you have 2. When you start creating your cluster, you have 2 worker nodes. So both of them each have 1 Karpenter pod, and for some reason, you have pending pods. Karpenter kicks in, you spin up a new node, and then all of the workloads shift to the new node. So generally, it's not advisable that, hey, I think I will utilize this node more than the previous 2, the basic 2 that I provisioned at the start. I want to shift one of my Karpenter pods into the new node that I provisioned. So typically, it's not recommended. As of now, I haven't yet had a customer who did that. But what I imagine is it's going to be a little bit messy because that new node that Karpenter spun up, it's not for life. Like it will change. What if Karpenter decides that, hey, I don't need such a big node. I want to consolidate it into a smaller node. Then your Karpenter pods will get kicked out. And then the Karpenter will spin up a new node and then it will shift back in to a new node. So it gets a little bit messy and a little bit wonky because your Karpenter pods are supposed to be relatively stable. You're supposed to be placed on a node that has little to no changes at all. But if you placed it on a node that has been spun up by Karpenter, it will always change because it will be consolidated, it will be moved around. It's a little bit more unstable. And you might be faced with a situation where your Karpenter pods aren't able to look at the incoming requests in time, and your scaling might fail because it's still in the process of consolidation. It's still unschedulable. It's still trying to find a new home. And then your scaling might even fail eventually. So when you're viewing the EKS blueprints, there's a choice to either deploy your Karpenter on Fargate or EC2 instance. If you want, of course, a more managed way of doing things, of course, EKS Fargate, you can just deploy your Karpenter on EKS Fargate. But if you still want to retain some control because you have specific requirements, you have golden AMI, you want to use it, then you can also deploy it on EC2. It's totally up to you. It's totally up to your preference. So in terms of when you're customizing the node pool CRD or the custom resource definition file, Ideally, if your workloads are able to jump around, you don't need your workloads to be that stable, then you should enable the consolidation feature to bring down the overall cost of a cluster. So if you want to, you can use the node expiration TTL, time to live, to rotate the nodes. So let's say a very common use case is that there's new AMI. So let's say you're using a default EKS AMI. Maybe when a cluster gets upgraded, your AMI will have a new version. If you want this to happen automatically, you can set it such that after 30 days, the nodes get killed off and the new nodes get spun up. So instead of upgrading it manually, like, oh, I need to change a new AMI, you don't have to do anything because after 30 days, the node will automatically refresh itself, create a new one, kill off this, move all the ports over to this new node with the latest AMI. So this is a common use case that customers are using. And of course, use a diverse set of instance type. So going back to our spot versus on demand, if you only have like a few EC2 instance that's running on spot and on demand, and you wish to optimize cost to the maximum, then use a more diverse set of EC2 instances. Instead of just having two, maybe have like 8, 10 EC2 instance. So in the rare scenario that AWS can't find a EC2 instance that is of spot, of the type spot, then if you don't have a diverse set, then you fall back to on demand and you won't get the cost savings that you desire. So lastly, in terms of scheduling port, I think this is pretty standard. It's not Karpenter specific, it's more EKS specific. You want to limit the range, you want to avoid noisy neighbors, you don't want one container workload to consume all of the resources that are in your nodes. So all these are pretty standard, it's not Karpenter specific. And I do have a simple demo that I wish to show. That you probably see how Karpenter works. Okay. So you can see right at the top, it's a cluster running on it's a cluster that is running on Karpenter as a scaling mechanism. And at the bottom is running on cluster autoscaler as a scaling mechanism. And you can see that at the start, both are running on M5.large. And now I will attempt to scale this demo workload that I have, which is pretty simple. So currently, both of these workload, my app dash deployment 1 is at 0. So I'm going to attempt to scale it to 20. So if you can see on the right-hand side, you see that there are 20 pending pods. It's not being scheduled to the two nodes that we have here because it no longer has any space to be placed there. Likewise, for the top, you see that there's like 17 pending pods because 3 of them can be placed in existing node. So you can see that in terms of Karpenter, it's really spinning up a new node, and Cluster Scaler is just beginning to spin up. And the next most obvious reason is that for Cluster Scaler, you're spinning up multiple M5.large EC2 instance. But for the case of Karpenter, you are spinning up one C5.4x large, which essentially brings down your overall cost of your cluster. If you look at the top, this will only cost you 140 per month, while at the bottom it will cost you $630 per month. So this is going back to the example that we had. If Karpenter sees that there's a large instance that you can provision to bin pack every of the container workloads that you have, it will provision that EC2 instance for your pods to be housed in. Whereas for Cluster Scaler, you have to have different node groups, and there might even be a chance that it might not hit another node group that can provision a EC2 instance big enough to house all your pods. So for this particular Cluster Scaler cluster that I have, I only have one single M5.large node group. So you'll definitely see only M5.large being spun up. But whereas for Karpenter, I left it rather open. It's only running on one single node pool custom resource definition file. And just so happens that it looks at the pod request. It sees that C5.4x large is the best and cheapest instance that I can use to house all of my unschedulable pods. So it will spin up that, and then all of your unschedulable pods will then go into this worker node that Karpenter spins up. So we've seen how it scales out. How about scaling in? So currently, 20. I want to scale it to 0. So obviously, all of the pods will be kicked out because previously I requested 20. Now I want none of them running. So all of the pods will be kicked out of the node. So in this particular example, right, for some reason, I'm not sure why, but the scaling out behavior is a little bit more obvious than the scaling in behavior is a little bit more obvious than your scaling out. So what I mean to say that is that the scaling in behavior will happen a lot faster when you're scaling out. It's a little bit more obvious. So you can see that currently all of the new nodes that you have provisioned, or both Karpenter as well as Cluster Scaler have provisioned, is underutilized. There are no pods that are running inside that's of crucial business logic or anything. So you can see that it has already killed off the node that has been spun up by Karpenter. Whereas for Cluster Scaler, it's still in the reading state. So which means that if you try to scale out your pods can still enter this EC2 instance. They are running, and every minute or every hour you run your EC2 instance, you are getting charged for it. But Karpenter immediately, once it's underutilized, will start killing it off so that no new pods can enter this EC2 cluster, this EC2 instance. So you can see now that it's starting to get cordoned off, but it still means that it's still running. Being cordoned off doesn't mean that the nodes are dying or like shutting down. It just means that it's not able to accept a new pod that's coming in. So it's still running. You're still getting charged for it. Whereas in Karpenter, you don't see it. You started off with 2, you increase to 3, and then you go back to 2. So this is the base state. Whereas for Cluster Scaler, it's still starting to spin down. You can see it's slowly getting spin down. It's cordoned. It is not completely shut down or terminated. So for some reason, I don't know why the scaling in behavior happens a lot faster than when you're scaling out. But the point I'm trying to make is that in terms of behavior, in terms of performance, Karpenter will definitely, assume all else equal, perform a lot faster than Cluster Scaler. So finally, after speaking for so long, Cluster Scaler has successfully and finally spinned down everything to its base state. Yeah, so I hope that was insightful. I hope that everyone is able to see the value proposition of using Karpenter over Cluster Autoscaler. I hope everyone actually knows what Karpenter is. I mean, if you have any question, you can connect with me on LinkedIn. We can talk about it. Or if you have any question now, in fact, let's just address it all, because whatever questions that you may have is not stupid questions. People might have the same question but are afraid to ask. You can just break the ice by starting. Come again? Low requirement. Sorry, I'm still not getting your question. Costlier instance for which one? Cluster Autoscaler or Karpenter? For Karpenter. So if I can bring up so this is my Terraform file that I have. You can see that in this requirement, these are the requirements that I've stated. I only put C, M, and R. So in that particular scenario, Karpenter has determined that C5.4x large will be the cheapest of them all. You can see that I have C, I have M, I have R, I have Spot, I have On Demand. In terms of like instant CPU, I have 4 all the way to 64. And in that particular scenario, Karpenter has determined that the C5.4x large that's been provisioned is the most cost effective and is the most suitable for the workloads they are requesting the resources.
In a daily tasks, like we build a AMI, push it every month.
Yep.
So every month I need to update AMI, make sure all my instances using the new AMI.
Yep.
So does Karpenter automatically detect the new AMIs with the new machines moving whatsoever?
So the only thing that Karpenter detects is that if the control plane of EKS as well as data plane is of a different version. If we want to achieve what you have mentioned, then by default, Karpenter, you can specify the TTL, the time to live. So every 30 days, we will refresh the instance so that you can be, let's say for example, every 20 days, you update your AMI. You can choose to configure Karpenter such that at the 21st day, one day after you spin up a new AMI, it will queue off the nodes of the older AMI and then spin up a new node with the new AMI.
Detect the new AMI using the tags.
Yeah.
And also, does it take the nodes? Like suppose say I want some nodes using the stains.
Yeah, it's doable as well.
And when a pod is pending with particular tolerations, so does it detect, okay, it can be scheduled to a node with the stains and
Yep.
exactly that.
It's doable as well. It's configurable. So this is what I meant whereby I say Karpenter has a lot of flexibility to play with. Stains, toleration, no affinity, and all of these instance requirement according to your desired state, everything can be done and can be configured. Of course, whatever that I'm showing you is just a base case. It's a bit simplistic. But if you want, we can probably get into a deeper discussion on how Karpenter can help you achieve your workload. So if you can see in this example, right, I only have one single node pool or provisioner. In an ideal state, you wouldn't want every single services or services that you have to be only using one node pool. Let's say what happens if I need to have a GPU instance. Ideally, I wouldn't want it to spin up C, M, and R. And if I leave it as it is, right, your workload that requires one GPU or requires a G instance type, Karpenter will just, oh, okay, I need to spin up the cheapest version, the cheapest EC2 instance for it. It will just spin up a C5 Spot, for example. So
when we see as perspective as well as availability perspective, like this Karpenter might be in a business of reducing the cost, like moving the all back, reducing the availability. So how can I choose like okay, I need to say only this much, and I need this much for liability. So don't do it.
Yeah, so everything you can do it with a combination of port disruption budget as well, so that you ensure that at any given point of time, 40% is still running, or 60% you can just move around. I don't really care as long as eventually it brings down the overall cost of my cluster.
I want to actually do kind of once a machine spins up, I want to use a data script. I want to like maybe do some kind of deadline. I had some install something that we had not been to install maybe some agents like actually some agent. And so can I do all these things before it's deploying the I mean, I want to do some health check. Okay, this node is ready. Okay. So can I configure the health check on Karpenter?
So typically that is being run at the infra level or the app level? Infra level. So I believe you can run some scripts before these instances are being launched as well.
The cloudy scripts.
Yeah.
Cloud. How does it join lower Kubernetes cluster?
Come again?
How does it join the Kubernetes cluster? What are the nodes?
Karpenter?
Yeah.
Because it hits so Karpenter currently is only available in if you're using AWS EKS or Microsoft AKS. It doesn't work on on-prem yet.
But so it need a node to join the Kubernetes cluster, right?
So all of these are done at the back end. So the moment it provisions, so let me go back to the slide. If you see this, it's trying to see what's the cluster name as well as subnet. So there's some discovery being done at the tag level. So it knows that it's supposed to join once a new node is being spun up, it belongs to this particular cluster. Sorry? That I'm not too sure. I might need to check on it. Yeah. Yeah, it supports. It's just that it can't do slicing. Yeah. Yeah, slicing is not supported. Come again? That I'm not too sure as well. Currently, it's open source. So if the open source community decides to release it for for on-premise Kubernetes, I mean that's possible. Because this is no longer owned by us, it's actually being donated to the CNCF Foundation. So anyone can technically use it and plug it and play it. Yeah, you might need to reconfigure the whole logic. Any final questions before we move off? For everyone is like expert in EKS now. Everyone knows how to use Karpenter. Well, I'm hoping to see that the Karpenter will come back to go after this session. So essentially, there's no strong reason why money don't support your first so if you want to optimize everything right.